Good afternoon, everybody. As Jen's just mentioned, my name's Dave George. I'm from Newcastle University. I was previously at Stockbridge working with Jen at the start of the DIVERSify project and left about 2 years ago, but was very happy to still be able to be involved in the work we were doing in DIVERSify around looking around barriers to plant team cropping and trying to identify some of the solutions to the different types of barriers that Jen's already mentioned. I guess my role today is really to introduce some of that work and talk about it in a little bit more depth and cherry pick a few examples of the solutions that we'd identified to plant team barriers, both in terms of sowing and management of plant teams, which I'll talk about now for 15 minutes or so, and then in terms of harvesting and processing as well, which I'll talk about after coffee this afternoon. And really the aim of these short presentations isn't necessarily to completely cover everything that we did within DIVERSify in terms of identifying these solutions. It's more to introduce some of them, to introduce some machinery solutions, to introduce some precision agricultural technology solutions, and set the scene really for the panel discussions that will follow both of those presentations. So just to pick up from where Jen left off when she was talking about the work we'd done to identify and classify some of these barriers to plant teams. Jen's already mentioned that we had drilling barriers, agronomy barriers, harvest barriers, and other barriers as well. But we actually, in terms of when we were reporting and when we were looking at how we could structure some of those reports to make them as useful as possible for people that might want to read them and learn from them, we also split those agronomy drilling, harvest and other barriers a little bit further as well. So within drilling barriers there, you can see we were looking to identify solutions to challenges around multiple seed sizes, around multiple seed rates, around having to drill potentially different plant team components at multiple seed depths, and potentially having to drill them at different times as well. And in terms of agronomy, we were looking at challenges based around pest control, disease control, weed control, crop-to-crop competition, and nutrition complexity. And you can see, you can imagine on the DIVERSify symbol there on the right, if you've got those three quite different crops all growing together, you're potentially looking at three very different seed sizes that you need to somehow drill, potentially with the same machine, especially if they all need to go in at the same time. And you might also be looking at pest challenges on one crop that might make it difficult to select a product to use if it's not registered for the crop that's growing next door to it. So what we'll do is I'll spend a couple of minutes giving a few general introductory slides around how we also, as well as classifying our barriers in this way, how we also split some of those solutions according to plant team type, which I think is also something Jen touched upon. And also according to whether some of those solutions are sort of readily available or whether they actually needed prior engagement with certain machinery or precision agricultural technology, or whether they were actually a bit further away from the marketplace. So really, it was one of the things that we didn't intend to do really when we started bringing together and looking at some of these barriers and trying to work out how we would present them in a meaningful way. But something that we found quite early is that it was probably important when doing that we actually both classified the technology, so looking at whether it was accessible, available or attainable, as I've just mentioned, but also looking at whether those solutions would apply to all plant teams or whether in fact they were solutions that would only apply to different types. And certainly two different types of plant team stuck out as we were going through this exercise. And those were structured plant teams and unstructured plant teams. And hopefully this picture here that you've probably seen a few times already will help me explain what I mean by a structured plant team or an unstructured team. So this is a photograph of some of the work that we've done at Stockbridge Technology Centre, working with CHAP and also with Manterra. And we're lucky to have Andrew Manfield on the panel later on, who heads up Manterra, Precision Agriculture and Machinery Specialist. And what we were looking to do was to test whether we could grow cereal crops primarily in understories, permanent living understories of clover. So a living mulch of clover, as we called it. And what you'll see in this picture on the, I hope it would translate around the same way, on the left-hand side of the screen is the standard monoculture, which we were comparing against in this experimental system here. And we then had what I would describe as an unstructured arrangement of the clover and the cereal crop on the right-hand side of the screen. And that's really where we're just direct drilling straight into 100% clover cover. So there's no real structure to that clover underneath. It's there at random almost. So at least one component, at least one species in that plant team is unstructured in its spatial arrangement. And what we were trying to do with that project was to engage with, and this has also been included within DIVERSify, this work, is to engage with modern machinery and precision agriculture technology to allow us to use a strip till to go through that clover before we actually went in and drilled the cereal, to allow us to actually cultivate effectively half the field in strips, and then place the cereal in those strips that we'd cultivated. And what we were trying to achieve there is really the benefits of the two systems on either side by structuring that plant team in some way. So in this case, it's a little bit like sort of strip intercropping, if you like, but we're doing it with the clover. And we would hope that the benefits we would see from that is that we would allow the cereal to get away earlier in a cultivated strip in between the clover. So we're minimizing competition, minimizing some of the drilling issues to help get the crop away nice and early and realize its yield potential. But we're also retaining the benefits of having the clover there, as we would be with the unstructured plant team. And well, then I think it's important to introduce this concept, because it certainly seems to have an effect on how well barriers can be overcome, whether you're able to adopt a structured plant team with admittedly some of the capital investment and machinery that's needed to realize them quite often, or whether actually you might be sort of entering plant teams, but sort of at the beginning of a journey, and actually you might want to start with an unstructured plant team. And as we go through, I'll talk about how some of those, how structuring or unstructuring has an impact on how well or how easily you can overcome some of those barriers that are associated with growing more than one crop in the field at the same time. I think another important point to note is that when we were thinking about what is a plant team, we weren't thinking about something like a cereal that's followed by a cover crop. We were thinking about things teams that fully overlapped in time, as well as space. And this was I don't want to talk too much about this, and I don't want you all to sort of lean into your screen, squinting, trying to read all the very small text. This is just to show you that the output of that activity, looking at all of the potential solutions to all of the potential barriers, was to produce a troubleshooting matrix of practical solutions to plant teams, and it's split by whether they're structured or unstructured. This is just a part of one of those matrices that we created, and these will shortly be released on the DIVERSify website, so you can look at them in more depth there. But this is how we've actually taken that information and sort of brought it together and presented it. And you can see this is the troubleshooting matrix for structured plant teams there, and this is probably about a third of the full list. And you can see we've grouped things according to whether they're machinery solutions in the orange ovals, whether they're PAT, Precision Agriculture Technology solutions in the blue, or whether they're actually product solutions in the green. And that's something that we hadn't anticipated, that we would also be potentially looking at products that might help us to grow plant team crop arrangements. And then the shading on the right-hand side is just looking at whether something's accessible or whether it's available or attainable. But yes, I don't want to dwell too much on that. That's something that you will shortly be able to download from the website and have a look at yourself to get the full overview of all the work that we've done around solutions to plant team cropping. So moving on, I just want to give now a couple of examples from those sort of full matrices to try and generate some discussion, as I mentioned earlier, as we move into our first panel session. So picking a couple out for drilling, for agronomy. The first one here is looking at fertilizer spreaders. So this is an Avadex spreader here. It's something we're looking to get Newcastle University farm shortly to help us with potentially with cover crop establishment into standing crops, because we don't have a very big window to actually get our cover crops off and away, so we can't really wait until after harvest to try and get them in. So we'll be using one of these to actually apply, or look to try and apply cover crop seed. Of course, it's an Avadex, it's a sort of fertilizer spreader, but it can just as easily be repurposed, if you like, to spread cover crop seed. And that's something that I think a theme that's true of quite a lot of the machinery solutions that we sort of managed to uncover as part of the project, is that they were typically not necessarily specifically developed for establishing plant teams, for example. They may have been designed to achieve another goal, but they could quite easily be repurposed and used to spread seed. So if it spreads fertilizer, if it spreads granulated fertilizer, it's relatively straightforward to have that piece of machinery like this spreader here also apply seed. So in this example, it could be something that we use, for instance, to establish our clover in a clover living understory arrangement. I guess at the other end of that spectrum would be something like this, and this is a drill, sort of a combi drill, really, and a lot of the sort of more modern combi drills, I suppose, that are being designed particularly around no-till systems, around regenerative agricultural practices, tend to be quite configurable. So you can actually bolt things on, and you can sort of be quite inventive in the way that you actually set them up. So again, even if they're not necessarily designed with plant teams in mind, they can be tweaked and looked at and set up to actually do quite a good job at, for example, handling multiple seed sizes or drilling seed at multiple depths. And I'm sure this is something that our panel members in the next session will be able to talk at more length about, for example, the drills that they're using and the plant team combinations that they're able to realize with those drills. This is one that I particularly wanted to flag up because it's one that I saw at Lammer when we were back before COVID, when we were all allowed to go out and play. I actually saw this piece of kit being advertised and exhibited there, and it was actually the first piece of machinery I'd ever seen where it was being marketed with plant teams in mind, so actually specifically for plant team cropping. They didn't actually call them plant teams, they didn't call them polyculture, weren't called intercrops, and it was a term I hadn't come across before, but it was looking at this bednar system to grow winter wheat, winter rapeseed, and there were a few other posters up as well with different crops, with what they were terming an auxiliary crop, and that was a term I hadn't come across before, so that was also an eye-opener, realizing that actually we may have been missing some machinery or some pre-existing information on plant teams because we weren't aware that the term auxiliary crop was being used in different parts of Europe. But yes, that was a sort of nice piece of machinery there that I thought I would, again, that I could have used. It could be any number of drills. I'm not getting any form of kickback from Bednar or anything like that. But I thought this was a particularly nice example, and one of the first examples I've seen, at least, where they're actually marketing this particular piece of kit, but because of its ability to establish these auxiliary crops and drill them. And you'll see at the bottom of these two posters here that sort of quite configurable design to the Bednar system, where you can pick different bits of machinery depending on what you want, what your end goal is. Of course, pieces of kit like that, direct drills. At Newcastle, we use a John Deere 750 that we work with there. They're quite big bits of kit. It's quite a lot of capital investment if you're perhaps starting out on a plant team journey. And it's probably worth asking the question, is structuring worth the extra capital investment needed in terms of modern machinery? And really, if you are structuring, and probably in terms of precision agriculture technology as well, GPS, RTK steer is becoming sort of far more common. I would say it probably depends what you're looking to achieve, and certainly as we'll move on to the agronomy slides next, I think that's where you start to see some of the additional benefits to structuring, particularly if you're looking to go down a plant teams route. And when I first started working at STC, we were sort of looking at that machinery, that sort of modern machinery and the precision agriculture element to it, to grow similar sort of systems to this one, but without the added crop, just for cereals, for example. So just band sowing cereals, so that we could then be very precise with fertilizer inputs, or we could potentially band spray fungicides to be more cost efficient and possibly more environmentally friendly with those inputs, which again is something that's likely to become more important as we move forward, certainly in the UK, with ELM's sort of post-cap support systems that are more targeted to the environment and to biodiversity, etc. And that's when I first sort of met Andrew, when he was doing some of that work at STC, and at the time where you'll see a sort of a companion crop growing here with the cereal, that would have been bare soil, because we were just looking at those input efficiencies. And I got very excited when I saw it, because I've been working on sort of plant teams for many years since my PhD, but never really spotted a way to realize their value commercially. When I saw that strip of bare soil in that band sown cereal plot that Andrew was working on, I sort of looked at that and thought, well, maybe we could actually put some of those planting arrangements in there. And that's exactly the sort of thing that's happened here. Like I said, when it comes, or as I've sort of alluded to there, when it comes to the agronomy, those structured arrangements certainly seem to open up more possibilities for precision inputs of nutrient or of liquid fertilizer, potentially if it's band sprayed, of pesticides, of fungicides. And it's not necessarily just chemicals either. If you look at some of the kit, I think this is a sort of ones from Garford. It's one of the sort of precision hoe. You can start to open up more possibilities for engaging with this type of kit when you're looking at structured plant teams, and that's certainly something that our work has suggested is the case. And I'll show you a graph later on where we've actually split apart the numbers of solutions to plant team cropping based upon whether it's structured or unstructured. And it seems that there are more solutions for structured teams based mainly on, particularly if you've engaged with precision agriculture. That doesn't necessarily mean, of course, that all agronomy solutions aren't available for unstructured plant teams. And this is a good example, if I can get it to play. Hopefully, yes. Of something called a comb cut. So this is a sort of a piece of kit from Prime West, again, something which we're looking to, or hoping to get hold of at Newcastle in the not too distant future. Where again, you're using a very mechanical means of managing, well, this is sort of managing weeds here, but potentially, again, repurposing that to be something that could address some of those agronomy barriers in a plant team, an unstructured plant team setup, where you're able to go through a cereal crop and potentially manage either the plant team that's in there, if you're trying to potentially hold it back a bit, or to manage weed pressure in a plant team if you had a clover understory that was growing underneath. And we're quite interested in whether this piece of kit can help us with some of those clover living mulch plots that I mentioned earlier. Also, it doesn't mean that chemistry is completely out of the question for unstructured plant teams. So even if you haven't got a structured plant team where you can potentially apply chemistry in a very precise way, and your plant team's unstructured, it doesn't mean that there's absolutely no chemistry out there, but it probably does restrict the amount of chemistry available. And really the examples of something like this, for instance, a herbicide that is potentially safe for a plant team are very few and far between. And this is an example here called Clovermax, which we've tried, and again, sort of played within the STC living mulch plots for weed control. And I guess they're the sorts of things that have probably been developed for mixed pasture. I did want to quickly mention some of the trials that we've been doing both at STC and at Newcastle in a collaborative project called Crop Health North, which has been run by Yorkshire Agricultural Society through the Farmer Scientist Network. But we've been looking to try to realise the potential of some of the biopesticides that have been coming through, particularly in horticulture, and used in cereal crops elsewhere in the world, things like Serenade, for example, that's used in wheat elsewhere, to look at whether they would possibly be of benefit within plant team setups, because a lot of those biopesticides might well have broad approval, so that they're likely to come through and be approved on more than one crop at once. So if you had a plant team arrangement where you had two crops together, it's possible that some of those biopesticides that do come through and sort of have blanket approvals might actually be permissible for application to both of those crops. And certainly with this work here, where we looked at sort of biopesticide regimes where it was either biopesticides alone, biopesticides mixed with conventional fungicides, or synthetic fungicides alone, we did see some benefit to those products when used outdoors in the UK to target septoria, both in terms of yield there, protein, and also of average septoria infection per plot. So I think that's probably one to watch for the future. It's not really an option that's necessarily available now. But as more of those sorts of products start to come through for outdoor arable crops in the UK, we may see more solutions open up for plant team agronomy in terms of pest and disease control particularly. This is the graph I mentioned, where we see that when we look at how many potential solutions are available for drilling and agronomy barriers in unstructured and structured plant teams, we encouragingly see that solutions are available. We've managed to identify solutions. There isn't anything there where the figure's 0, apart from perhaps we're looking at some sort of attainable solutions. But you will see that the numbers of solutions on the right there for structured plant teams, overall, there are more of them than there are for unstructured plant teams. And that sort of follows on from what I said earlier, where if you're starting to structure, you're then opening up more possibilities, particularly through engagement with precision agriculture, for precise input management to address some of those agronomy challenges and some of those barriers to drilling as well. Another point on agronomy is that, and I think, well, a point on that sort of probably covers most of the barriers that we identified in the project, is that there's potential to realise inputs in terms of agronomy and also realise benefits in terms of things like drilling by careful selection of the plant team itself. So here we have an example. This is the Three Sisters, which is the classic example of a plant team. The sort of historical example from very early in the days of agriculture, where we would combine maize, beans and squash to sort of realise the synergies between them. So the maize would act as support for the beans would be providing nitrogen as a legume, and the squash would be sort of creating a living mulch as a carpet to help suppress weeds. And for things like pest control, careful plant team selection may actually allow you to overcome barriers to realise, for example, not being able to use pesticides, by making the plant team actually deliver a pest control service itself, as long as you've selected the right sort of plant team to do that. And this again is something Jen touched upon in the introduction, where she, I think, may have even shown one of these graphs where we've done, again, some work at STC on a separate project funded by the RPA, where we've found that with that same sort of clover understory, as soon as we start to diversify away from monoculture, we start to see benefits both with the full clover cover or with strip-tilled clover there on the graph, to aphid control, for example. Or we see benefits there in the graph above to weed ground cover, because we're not allowing the weeds to get established by having lots of bare ground there. So that's where I'll leave it. I don't want to talk for too long. I've already had 23 of my 20 minutes. So here are just a few points for discussion to maybe help inform the panel discussion next, and help generate some thoughts and some questions that you can send in by the chat function. So do gains from structured plant teams justify the capital needed to realise them? Are ecosystem services reliable enough to provide agronomic inputs like pest control by just picking the right sorts of plants to put together? Is PAT, precision agriculture technology engagement, a prerequisite for benefit for plant teams? And how can I pick and mix plant teams to help with my drilling and my agronomy? Excellent. So I'll leave it there. And what I will do now is introduce our panel.